As we talk about the different parts of the ecosystem that people hack, data, of course, is our primary concern. One of the things that's evolved over time with data, of course, is that we now have these huge collections of data. These collections may be in traditional SQL databases, they may be in buckets or SAN storage and flat files, they may be in NoSQL environments. It doesn't really matter because what we have are huge collections. And these huge collections are rarely segmented, meaning once you get in, you're in. You have access to everything. You should at least take, say, your contacts collection and store it separately from your transactions collection, and then have different security rules on that. But we rarely do that. The other problem with all these tools is that there are lots of different ways to exploit that data. Some of these tools come with UIs or APIs that we're not securing in the same way that we're securing our primary access to the data. A lot of times there will be verbose logging that will actually give almost a copy of some of this data as it's accessed. And of course, with legacy systems, we have backdoors that need to be locked down and secure, but sometimes we either forget about them or just never get around to fixing that. Of course, you can say that the data is all encrypted. My feeling is that encryption is a myth. Let's start with encryption at rest. Encryption at rest is where you take the physical file system and you encrypt it. So if somebody gets onto that operating system and steals the file, it's encrypted and they can't read it. In the day and age of managed services with things like S3 buckets or DynamoDB and Amazon, we never see the operating system. The only way we ever access that data is using a key pair that has access. And when we have access, like I said before, you get access to everything because we don't encrypt individual records. That same key pair that gets us in there, that has already decrypted everything that we said was encrypted, now has access to everything. Again, if we have a contacts collection, I shouldn't be able to read every single contact with one key pair. That single key pair that has the ability to decrypt everything just leads to obvious abuse. You need separate keys with different access depending on why, and you need to be careful about how you dole those out. And then there's the actual how you're doling that out, the credentialing for the database. When you have an application that accesses a database, it's usually given a service account, and those service accounts usually have a lot of access. That means the database isn't actually user aware, meaning if I'm an individual logging in through an application to get access to data, the service account is actually getting that data on my behalf. Now, with good API structure, it shouldn't be able to do that. But again, it's not always possible to do that kind of locking down at the API level, so we need to consider ways to lock it down at the database level when possible. And ultimately, administrators should not be gods. A lot of the times when we see hacks, it's because it's a disgruntled employee who had a lot of access. We shouldn't be able to see everything. I don't want to see everything. But by the nature of our normal design patterns, we create a god pair of keys, a super admin who is able to read everything. And that just really should not be.